turning traditional batteries safer, like they last longer and charge fast.
TioTech is a materials company. We're really good at making powders of nanomaterial. You don't need to buy new equipment, relatively less energy demanding than kind of existing ways of handling and making nanomaterials, which typically are quite energy intensive.
Growing a hardware startup, specifically in Europe space, is already difficult. And specifically when you're working on a technology that is so unique.
What happens if you don't have to look for a charger or you don't have to worry about range because it takes 3 minutes to charge your battery? You don't have to worry about leaving your phone charging so that you can kind of have a full battery whenever you leave, because it can do that. What happens if you have batteries that you can crush, roll over?
Hey, hi Anders. Thanks for joining us on Scouted by GreyB, and it's very nice to meet you finally. I hope you're doing good.
Thanks. Hope you're doing okay.
Yeah, I'm doing great. So Anders, before I dive in, is there anything exciting or surprising that has happened recently in TioTech?
Oh, where to start? The focus and kind of the exciting things we're doing now is our scaling up. So we've just kind of bought our first real industrial sized equipment to have installed here as our premises in Bergen. We've got some really cool stuff going on the customer side, which is a bit early to talk about, but it's very interesting, kind of forward leaning, looking at new applications of batteries.
I'm sure it will be very exciting, and I'm going to ask you about it. But still, for our audience, I'd like you to share, if in like plain language, what is it that TioTech is doing, and basically how is it impacting the current battery industry?
TioTech is a materials company. We're really good at making powders of nanomaterials where we can control the size, the shape, the composition of our particles in a highly controlled and also scalable manner. And what we've done is use materials that are being produced already at scale, repurpose them into nanomaterials, and then innovate in the battery space. What we do is we take Titania, which is probably the world's most boring material, and it's not a battery material. But then we go down the line and say, okay, what if we tune that into a nanomaterial? And what opens up is actually a way of making super safe, super long lifetime, and potentially also super fast charging batteries.
I'm getting it right. So you are turning traditional batteries safer, like they last longer and charge fast. Right. So can you tell me a little bit on the technical side of things? Basically, how are you able to do this? And basically what I know so far, and please correct me if I got it right or wrong, you have picked traditional lithium-ion based batteries, and you're using Titan B. You have made them more safer. So how does the technicalities work of it?
LTO batteries are kind of the best battery. The only problem is they're not very energy dense and they're super costly. So even today, you'll probably have to go at like around $500 per kilowatt hour to buy an LTO battery, at least for a small project. But what we said is kind of, for this to become mainstream, what we really need to solve is increase the energy density, and you should lower the cost. Using Titan B, you can increase that storage by quite a bit. We're targeting a 50% increase of Titan B capacity, and you can also reduce the cost. We use the same raw materials that go into standard titania production, white paint basically. So it's a pigment. It's super cost efficient in terms of the raw materials. And then because titania in a pigment, you can't just put that into a battery and expect to get a good battery. You need to have our kind of type of process, which basically means we have a chemical solution, and then we can control the pH, we control some additives, we control temperature. And from that, we can then control the size and the shape, and to some degree also kind of the composition of those materials.
Got it. I wanted to ask is, when you said ideal customer, we are talking about battery manufacturers specifically, right?
We're open to working with anyone who wants to pay us. I mean, yes and no. We have some ideal battery manufacturers that we love to work with. So kind of the ideal customer is probably someone is actually quite integrated. It's more like a consortia of companies that are working together on solving these issues and want to have us on board. That's kind of the ideal case for us at the moment.
What kind of challenges is TioTech's team facing, or maybe you might have already solved it, in terms of scaling of the production?
I think that the kind of main problem now is kind of moving from what we've done up until now, which is, and we'll still do that in the pilot, where you do part processing here, then you move on to batch processing here, then you move on to batch processing here, and moving from that, and moving from the paper exercise that you've done in terms of showing that unit costs can come down to an acceptable level, to actually proving that they will come down to an acceptable level. And those are kind of the main now risks in terms of scaling and in terms of what we can offer to clients. We are dealing with some chemicals that are hazardous, that are acidic. So we are dealing in an environment that is not the easiest to work with. It's not the greenest, put it that way, of chemicals. It's quite hard acids. So how do we handle that? How do we handle the logistics? Because in the end, it's kind of like you need to build a solution, and that solution might not be 100%. It might be the 80 or the 90% solution, but it has to work 100% of the time.
Yeah, and I also think that, growing a hardware startup, specifically in Europe space, is already difficult. And specifically when you're working on a technology that is so unique, and that's like basically the USP. So all of this gets added to the scaling issue. And of course, thanks for sharing that the different aspects of scaling challenges that your team is already solving. And I wanted to understand how easy it is, or you could say how difficult it is, implement or integrate Titan B into existing infrastructure.
The short answer is it's doable. You don't need to buy new equipment. You might have to buy some different chemicals. You might have to optimize your equipment and kind of change a few parameters on your slot widths or slot heights and stuff like this. So the very simple answer is yes, it's integratable. We've got very, very tiny particles that we then have to kind of control how we also put them together so that you get a powder that behaves in a way that you can actually use them in batteries or battery production lines. So kind of at the base, there's no problem taking our powder, putting it into a slurry, putting that slurry onto to a metal foil in a pilot line. That's not to say that it's easy. And that's not to say that we have full control over all the parameters and can kind of go into any battery manufacturer and say, okay, you only need to tune this dial and this dial. It's a validation thing. That's also kind of where we're still optimizing the full electrochemistry and looking at how we can tune all of the other components in a battery so that we can optimize that. And that's a tough job.
Again, I'm very curious about this technology, and that's why I'm coming up with these questions. So I also wanted to understand the sustainability side of things. Basically, what's the picture looks like when I look at it from sustainability point of view? Because there are a lot of guidelines and regulation in Europe itself related to battery recycling and manufacturing and disposable. So can you touch up a little on that?
What we do is obviously we work on our own process. We believe we found a process that's relatively less energy demanding than kind of existing ways of handling and making nanomaterials, which typically are quite energy intensive. But obviously our process really is a refining of a raw material type thing. We don't handle the mineral ore. So a lot of the kind of CO2 emissions, sustainability footprint is actually in the down or in the upstream production of our raw material. We have a supplier in Europe now who is, if not world leading, then at least quite on the forefront and have their own kind of sustainability roadmaps. Right now we're really lucky because we're getting it from a French manufacturing site. So it means we have very low, it's nuclear power. So the energy that's put in there is quite low. But like what they're also saying is that I think somewhere between 60 and 70% of their emissions is elsewhere. But then you're talking about recycling. Part of the problem with Titania is that it's so cheap in the kind of natural ways that you use it, that recycling of it has kind of been a academic study, because it's very hard to get it to become a cost-efficient process. And that's kind of my main worry really about batteries becoming so cheap that they are now, is it kind of is going to put back a lot of the recycling by a long way, because basically it's too cheap now to recycle. And then you end up as battery manufacturer, you design batteries that have lots of different chemicals inside them, lots of different components, lots of additives, which means that it's very hard to recycle.
Get the picture. And of course, this is not an easy problem to solve. It's the longevity of life, as you already mentioned, the increase in lifespan and increase in more robustness and the overall reduction in cost. I think that also kind of offset a little bit of this recycling challenges and then of course down the line they will be solved, because it's not just one company working on these challenges. There's like whole countries involved, and there are lots of guidelines going on, and government is also supporting a lot of sustainability efforts. So I think this problem will be solved, of course. I think I just have a few more questions left. I won't be taking a lot of your time. So what's the next plan, basically? What's coming in, let's say, in 1 year or 2 year?
Yeah, I think right now it's kind of scaling and validation is the two things we're really looking into. And that's kind of, if all goes well, in a year's time, we would be able to kind of say, okay, now we can start moving ahead with more kind of really kind of the first steps in terms of becoming a commercial entity, in terms of building the first type of factories.
Thank you for sharing this. And just one more question. And again, this is something for my personal curiosity. Still, you've made something very unique and you're solving a very critical problem in the industry. And usually it's difficult when you start a new company. And I think every founder goes through this, that maybe this is not going to work, or maybe this might fail, or maybe we won't reach the place we want to go. But what's your way of dealing with it? And basically, what do you think has worked out in your favor to get TioTech where it is today, and hopefully help you in taking it even higher in future?
I think starting a new venture, if you don't accept that it might fail, you're going to be struggling to take the kind of opportunities that present themselves. That's kind of the, I mean, complete honesty, like that feeling of it might not work. You have that, if not every day, then at least once a week, where you kind of go and you're frustrated and all of these things. It's impossible. It's also, you have a responsibility towards your employees, your investors, and all of these things. It's pressure. Yes, you can try and be 24/7 for a while, but I doubt that you can do that for as long as it takes to build a deep tech startup, because that is such a long haul. You're in it. It's a marathon, and a marathon that you can't just kind of go with lots of little sprints. You have to be able to work kind of consistently and build that. And that's kind of, I think, building a routine is probably the best thing. I mean, I have great people around here working with. I love coming into work. I've recruited people who basically said, I want to work here because when I came in, people were laughing. That's such an important thing, to hear laughter, to hear that kind of positivity. I come from a scientific background as well. So it's kind of like, I know that 99% of the things you do don't work. So you have to really, really focus on the things that do work.
I really had fun talking to you and getting to know all of this. So, okay, I think with that, it's the end of our interview. Again, I'd like to thank you for joining us and taking us through this journey.